Okay, let's look at question 26 in the end of chapter 9. They give us an equation that happens to already be balanced, and they are asking us what mass of IF, so that's iodine fluoride, must be used to produce 30.0 grams of nitrogen triiodide, Ni3. And Ni3 is the product. There's a B part as well, and they're asking you what the maximum mass of byproduct, BF3, is also made. And it's called a byproduct because it's the one that you're, according to them, less interested in. So how much IF needs to be reacted if you want to produce 30 grams? So you want to make 30 grams of product. How much reactant do you need? Of course, everything is related through moles in a balanced equation. Sorry, I don't know if it was already balanced or not, but anyway, it is balanced as it's showing. Either I added that 3 or it was already there. I don't remember. As a reaction pathway then, if you like, or conversion pathway, we're not in the lab. We want to start with the mass of the product and actually work backwards. So people often ask, where do I start with this question? Because they're, do I start with a molar mass? What do I start with? And in this question, we're going to start with the 30 grams of product, Ni3, and work backwards. So it's logical in the other problems where they say, here's so much reactant, how much product is formed. And that's a more natural way to think about it from left to right. This is the same idea, you're just working backwards. You can do this. So we'll start with 30 grams and say, well, I can't work in mass ever, so I'll take this mass, convert it to moles. And then once I have the number of moles, I'm using the molar ratio 1 to 3 to 1 to 1 up here. So once I convert the 30 grams to a number of moles, I'm not going to calculate it, I'm just going to keep going. Then I'm going to convert that number of moles of Ni3, which would come out of here, and convert to a corresponding number of moles of IF using this conversion factor, which again comes out of the balanced equation. So it says that 3 moles of IF react to produce 1 mole of Ni3. So it's 3 to 1. And you might be thinking, well, how did you know to put the IF on top and the Ni3 on the bottom? The answer to that is you have to look over here. You're converting from moles of Ni3, so you want that to be on the bottom here, which allows it to cancel out of that unit and into the one that you're converting, moles of IF. And then from moles of IF, you want to answer the question mass. So you convert from moles to mass using the molar mass of IF, which of course you can add up using the periodic table. So that's how that is done. The final answer, 33.3 grams, is in 3 significant figures as determined by the given 30.0. So again, 30 grams converted to moles using the molar mass of Ni3, and then converted to corresponding moles of IF that is required to produce that much through the balanced equation, and then a mass. What is the maximum mass, so maximum mass theoretical, of BF3 also made? And that's the byproduct. They call it a byproduct in the original question. And there is more than one way to go about this, at least 2 ways, given the information that we have already. Because all of the reactants and products are related through a balanced equation, you can use any one reactant or product to find out how much reactant or product, other reactant or product, you need to have to go along with it. So that's why you could start again with the mass of Ni3, which is known, converted to moles, and this time convert to moles to BF3 before mass. So same thing we did up here, except with BF3 instead of the other product, Ni3. Or you could say, you could think about it this way. We've just determined how much Ni3, or we were told how much Ni3 was going to be produced. Since it's a 1-to-1 ratio, once I find out the number of moles of Ni3, I could just say, well, that's the number of moles of BF3 and then convert that to a mass. And that's what we've done down here. We're going to use the top one. So it looks an awful lot like the calculation above in A. So going through it, we have 30 grams of Ni3. We're going to convert that to moles of Ni3 using the molar mass, 394.71. That brings us to moles of Ni3. We know that the conversion factor is a little bit different down here. We know that 1 mole of BF3 is produced with each 1 mole of Ni3 produced. So I can do 1-to-1 that way. That's a conversion factor. That brings me to moles of BF3. Using a molar mass, 67.81 grams, I convert to a mass of BF3. So that's how we do that question. All right. So the key message here is that once you have a balanced equation, you can use it to find out how much of this do I need to make that. If I want this much product, how much of that product also forms? Or if I want this much product, how much of this reactant do I need? Or if I have this much reactant, how much of this reactant do I need to go with it? So you see how all the possible combinations there are, and that really tells you how many different types of questions you should be able to answer. But it all comes down to the same idea. Chemical equation, balanced chemical equation, and always move from one species to another, whether it's IF to Ni3 or BF3 to Ni3 or what have you in this question. You can only move from one species to the other through the molar ratio of the balanced chemical equation. Always work in moles. Write that somewhere. Write it on your hand. Okay, that's it for this one.